Okay, so let's start by building over here our system. So we have geometry, and let's start first by creating the landscape. So I want you to create a grid, and this grid is going to be 20 by 20, and we're gonna give it like 100 rows. So something like this. I'm gonna use a mountain landscape to deform the whole thing. So let's set this up in such a way that we get like a good result. First of all, we're going to lower the frequency so that we are zooming in fact, on the noise pattern. Now we can see what's going on. Let's enhance the height so we have something more or less like this. And now we're going to increase the detail. So I'm going to increase the fractal depth, as you can see, so that we have like more of these details. And at the same time, I'm going to lower the roughness so that those smaller details are not going to be so prominent. They're still going to be there, but not that outspoken. So this is something we can use as a landscape. Now you see, if you look from the top side, we see this crossing. That's because the noise pattern we have is the Perlin noise is directly placed in the center, and this gives us this kind of result. Now you can use some different kind of noise types, of course. Alligator noise often gives also a nice effect, gives you the effect of some mountain landscapes, but let's set it back to Perlin noise. But important then is to make sure that you offset this value, that at least you're not anymore in the center of the whole thing. And so something like this could be useful. So the next thing that you need to do is to create a curve that you're gonna use. And this curve is then going to be used over the landscape. So I'm making this mountain right here as a template, and let's set our curve over here so as a road going over this landscape. Now it's important that we make it into a NURBS curve so that we have like this very smooth line representation. The thing what we're going to do is we're going to project this whole curve onto the landscape. So before we're doing that, we're going to resample that curve. And as you see over here, we have the resampling of this whole point. Now, important to know with the resampling is the level of detail. So if you lower the level of detail, you see, then the curve representation is going to be very rough. If you make it higher, it's going to be finer. So it's best to make it very high and accurate, especially because later on we're going to make some improvements on the subdivision of this curve. So that's the first thing. So the thing you could do right now as a small exercise is to try and project this curve onto the landscape. And what you need to do is to make sure that this curve is going to be projected on the landscape at all times. So no matter how high this landscape may be, for example, if you make it like 20 high, the curve is always going to be projected on the landscape. So that's your first goal. And if you don't know the answer, you can continue the video. Okay, so I'm going to explain what you need to do. First of all, you create an attribute create, and the attribute that we're going to create is going to be a normal. As you can see, I have a default sitting over here, something that you don't have, in which I set the op name. So the attribute, in my case, is going to get this name what you see over here. So it's taking the operator name as a name to put in over here, and with the backticks that I'm using over here, because this is a string, the backticks allow us to evaluate the expression that's been added over here. Now I'm going to remove this, and I'm going to call it the normal, or I can use my preset that I created and just name it a normal, as you can see over here. This preset makes it easier, of course, to set the whole thing up. So if we're gonna check this, make sure you always check these things. You see those normals appearing. One thing, I'm going to invert those values because I want to make sure that they're gonna be pointed down. So now we're going to take a race up, and this race up is going to project this curve onto the landscape. And using the middle mouse buttons, don't forget that, you can always check the input ports, what they're doing. And as you can see, it's being projected onto the landscape right now. So as you can see, the problem right here is that these curves are projected only for a small part. So what you need to do is to make sure that you transform this curve and make sure that it's moved higher above this whole thing. Now, to make sure that this goes all automatically, the thing you can do is the following. We can set the translation over here with a bounding box, and we're going to set it, and we're going to refer it to the mountain. And d underscore y max in this case. So now this is always floating above. Now, to be really sure, just add a little value to that as well, plus 0.1 or something, because it might be that one would touch the surface because you're setting it directly over here. So a small addition makes it really sure that you're always going to have like a proper projection of the whole shape. Okay, so that's the first part. So now if we're going to change over here, let's say the height, and then as you can see, this is all going to work just fine. Okay, now there's just a small detail that I want you to say, which would be good practice to do at all times. Now if we see over here, I'm pressing the shortcut D to display the options. And that's something you can do at each one of the views always. Pressing D shows you the options of either view. Now if you go over here to the dependency, you can show the local dependency links, and here you see the expression links that have been made. So the X form is using information over here from the bounding from the mountain, as you can see. Okay, so the problem is if you want to do some other operations. So best practice is to, for example, create a null. And this would be the object you should refer to. So I'm going to change this to null one, and that's good practice, especially when finding bounding box information, because right now I can add over here very easily a transform sub, and when seeing the results I can just start adjusting this whole thing, and as you can see, it will work at all time. Or I could just very simply create, for example, let's say a sphere, and that sphere I would increase it in radius, something like this, make it polygon, and increase the number of primitives. I can just connect it over here, and as you can see, the whole thing is getting projected over here on the sphere. So that makes it very flexible and very easy to use that way. So that's a good habit, to make sure you always set things up like this. Now we see over here our road going over this landscape, and the problem that we have over here is that it is too rough. I mean, you're never gonna have like a road exactly following the landscape, so we want to smoothen out actually the road. And there are various ways to do that. So also over here, it would be a good exercise for you to try and solve this yourself. So the idea is, and I'm gonna pause the video for now, in which I can show you what the result should be like. So this would be the result that I'm expecting from you. As you can see, we have still the rough landscape, but the curve that we see over here is smoothed, so it's not directly following all the rough shapes as we can see them over here. And so this is exactly what you would expect from a road to be happening. So they're going to remove all the rough details, and they're going to fill up the little holes, and they're going to remove like the small bumps, etc., to be as efficient as possible using a road. So this is the thing you need to solve. Okay, so if you want to see the solution on how to do that, I'm going to show you and present you with a few methods that you can use. So let me just remove this result again so that we have the original result as we have before. So one of the methods is you could smooth the curve. So we have the curve over here. You could use like a smooth operator. Now the smooth operator allows you to smooth all kinds of things. We have over here, it's applied by default to the point position. You can smooth also texture UVs, you can smooth color, or you can smooth other attributes as well. So you can smooth virtually anything you see over here. Now we see we have over here the cutoff frequency and we have like the smoothing iterations. Okay, now let's show a little bit what this is doing. Now if you see over here with the smoothing iterations, I'm adding like a lot of numbers and it's not doing a lot virtually. It's like smoothing a few of those smaller details, but it's not smoothing a lot, or at least not as much as we want it to. So if you change the cutoff frequency and set it to 3, then you have like the ability to smooth it much more, as you can see over here. But only having this is not enough, and I'll show you the reason why. So if you go over here and let's go to top view by pressing spacebar 2, you see over here this is our curve, and if I start to smooth the whole thing, then we see how this whole thing gets deformed. And this is not good. We only want it to smooth only in the Y direction and not in the XZ direction, because this is going to alter eventually our road, something we don't want. The points we see over here is a display issue, so don't worry about that. So what we need to do now is we need to make sure that the smooth operator is only going to affect the X, is only going to affect the Y direction and not the Z or the X direction. So how can we do this? Well, there are a few things that we can do. First one is, let's say that we are going to put the Y direction into a different attribute. So we're going to create an attribute, and you can name the attribute whatever you like. In this case, we're going to name it Y position. Now, I see a lot of people trying to use over here the local variable. That's not necessary. By default, the name, when you do an attribute create, the name of the attribute is going to be converted automatically to a variable as well. Now you can see that over here. If you middle mouse button click, you see custom variable mappings. So that variable that we created is going to have like this variable mapping. So in capital letters, ypos is going to be the variable. Now if you want to, you can have like a different variable name. So you could call it Bobo or something like that. So we check over here, Y position is now becoming Bobo as variable mapping. So just remove it and leave it as default. Now the other thing is we need to store over here the position. So if you go to your help file, and we're gonna check for variables, find, define a new variable. We have standard variables. These are the ones we're looking for, the standard variables. So if you go down over here, these ones are the normal vectors, and these ones return us the point position for each point. So in this case, I'm going to use as a standard variable, and that's something you can always access over here, the up point position. So in this case, $T, and over here $TY. That's the one we're going to use. So if you're going to check over here in this viewport, we see we have created a new variable called ypos, and we see right in here all the values being added. Now about this smooth value, if we start smoothing these values, you see over here all these values, and We start increasing that, and you see how those values are being altered. Now, the thing we're going to do is right over here is we're not going to smooth the position anymore, but we're going to smooth another attribute, and the attribute is the one we just created, y-pos. So if we're going to smooth right over here, we see that the y-pos is going to be altered at all times. So you can do this, and once you have that, we need to get that y-pos attribute back into the position itself. Now for that you can use a point node. A point node is very powerful. It's of course specifically related to points. Now you have that for all kinds of things. You also have like a primitive node, you have also a vertex node, and I'm not sure, but I didn't use it, you don't have a detail. Yeah, it makes kind of sense because there are no specific attributes to be used over there. But these are the three things you can use. Now, we're dealing with points over here. We're talking about the point position, so we're going to connect it over here to the point. We're going to remove these two. Now, we see over here, we have again those attributes which are getting the point position and returning that value. So, what we see over here is the current point position is being read and being written at the same time. So it's doing actually nothing. It's reading it in and it's placing the same value again and then creating all those positions. So what we're going to do is over here we're going to replace it with the attribute we've created, or as you can see over here with this new variable that we have. So we can use $y_pos in this case, and not position 2, but y_pos, like this. And so now you can smooth these values in the y direction, but if you look at the top view, you're gonna see that this is not going to change anything at all from the original shape. So this is very good. So that's one method that you can use. Another method is actually simpler than what we have over here. You can do exactly the same thing with only a smooth and a point node. So what you can do is over here you smooth the whole thing and you smooth also its positions, setting this to 3 again, so we're smoothing the whole thing. And I'm going to take the original positions of what we had, and the only thing that I'm going to do is I'm going to take the y position of the points from the second input port. So that's just leaving everything the same and just using ty2. And also this is working perfectly. So again, if we look at this result from the top, we see the changing result, but we're seeing this result over here. So I should check it over here. But then I can alter this. What I can do is I can pin down this view and then check the node over here. And so with that being pinned down, I am able to just slide around with these values, as you can see. And as you can see, again, in the X and the Z, it's not being altered anymore. But with both of these methods, there are still some problems, and I'll show you these problems, and they're especially towards the end, because what it's going to force it to do, it's going to force it to move into the ground or going to smooth it in such a way that it's not really practical. Now, why is that behavior happening? Well, you see that over here. If we look right over here at the smooth node and we smooth it, you see how all the points are being smashed or being brought closer. So this is going to alter it in a way we don't want it to be. Now, a more accurate way to do the whole thing is by creating a second version of the mountain, something we see over here. So what we're going to do is we're going to make, for example, a copy of this mountain, and we could reduce the fractal depth. Let's set it to a value of 2, for example. And now we have exactly the same mountain, but except it doesn't have like all these rough bumps anymore. Now there's still an issue over here, because if I change the offset, then we have like a totally different kind of mountain landscape, and this one is not able to follow. So what you could do is you could make all these links all by hand, but there's also something else you can do. So I'm going to remove this node. I'm going back to the original mountain node, and what you can do is if you right select on this node and you go down here, you find, and it's just outside of the viewport, but just a little bit lower. Let me try to get it back in. So if you click over here, you see right here a reference copy. And a reference copy is going to create a node with all expressions necessary to make like an exact copy of what's there. So as you can see, each one of those channels is being linked. So since we were adjusting the fractal depth, the only thing we're going to do is we're going to multiply the fractal depth by, let's say, 0.25, and like that we have a much smoother version of the landscape, and we're able to change over here the offset just like before, and everything is just going to move along. So now we're going to use this one to project our curve upon, and we're going to have like this mountain now being placed to the side. So this one is the rough mountain, and this one is a smoothed mountain, the one that we use over here with the race up. So all these things we can remove now. So this should be the first end result that we have, with the rough mountain, with the smoothed mountain, with our curve which is being projected over here on the road. Okay. So now what's going to be our second step? The second step is that we're going to create a road, something we're going to use to later on deform the landscape. So what I want you to do is I want you to create a small ribbon like shape, which is going to be used as something to project upon. Now let me create again a small example, and I'm going to pause the video over here so I can show you what I'm going to expect from you. So this is the result that I'm expecting from you. The first step is we see over here this flat ribbon. So all of these segments are perfectly horizontal, exactly what you would expect from a road. And so as you can see, it's going through the landscape. It's following with this smooth curve. So using a sweep node, you should try to get these results. Now you see the sweep node has like 3 input ports, so make sure that you check all of those input ports, read the help file, and especially try to work also with all the variables you have over here, or all the parameters that you have in the sweep. Many of them are very useful to use. And also what is really important is that you make sure that the line you're using, that it's always going to be centered automatically. So if you're not able to solve this, I'm going to show this to you now on how to do this whole thing. So let me again remove all the details up. That was the wrong node. Like this. So first thing that we're going to do is we're going to create a line. And we're going to make sure that this line is going to be oriented in the right direction. So let me just show what we have over here with, as we can see, this line pointing upwards. So we're going to change this direction. I'm going to make sure that this line is going to be looking in the X direction, as we can see right over here. So direction set to 1 right over here, and we're going to remove, of course, the vector for the up. So now we have like a horizontal line. And what we're going to do is we're going to use the distance in order to make sure that it's always going to be placed in the center. So just select a value, drag it over here, that you can create a relative reference. Now you see that the whole line is being offset with the distance. So if you make like a negative of that, oops, not the channel group, I changed it by accident. Now you see that the whole thing is being moved back by a value of 1. So if I'm scaling it now, you see it's moving from one side to another, but this is still not centered. So to center it, we have to take the half of this value. So by multiplying with 0.5, it's being placed in half, and so right now it's nicely centered. So this is exactly what we need to have. And by the way, this is something very useful to have at all times. So you can see over here we have X center, Z center. So we have so the thing which is really useful now is we have like this X-centered line, and as you can see, I have already have some of those stored as a preset, so make sure that you do that. So now we're going to sweep the whole thing, and if we're going to sweep this using this line, we're gonna see it's nicely centered, but the orientation of it is not exactly what we have in mind. So in the beginning it's still really okay, but the moment on it's starting to take its first turn, you see it's banking to one direction and then starts banking to another direction. We need to make sure that's going to be flat. So we have like the cross section as a first input, the backbone as a second input, but here the third input are the reference points, and you can use reference points in order to make it look or aim at something. So if you add a transform over here, and we're going to take the same curve, but we're going to move this curve just a little bit upward, then it's going to help us quite a lot. Now, by the way, you might notice something. The following is over here we see like these normals being all pointed downwards, and the moment on that we use this transform node, we see all these normals being altered. Now, especially with curves, that can sometimes pose a problem. If you're going to do now race up again, let's say, and you're using the normals, they're being altered. So what you can do is over here at the transform, you can switch off recompute point normals. The moment you do that, you see they're all being maintained again. So it's still going to work if you're starting to rotate the shape, etc. But it's going to make sure at least that those normals are not going to be altered. So whenever you have that kind of an issue, try to remember this thing. So now we have moved it up, and as you can see, everything now is set in a horizontal face. So if I'm starting to move this around, you can see how it's trying to aim towards those lines. So again, setting this up, making sure it's just moving directly above, and then it's using these points to place and these points to aim at. And so there we have our line. So the thing what you can do right now is we can make sure that we create it into a skin with auto closure, and we have over here our flat ribbon. So this is how you can deal with this. Now, to go a little bit deeper into what you can do with the sweep node, let me show you the following. If you create, for example, a simple curve, you can start up adding something like this, and we can create a line again, and like I've shown you, I'm going to use over here the preset of that line. And now I'm going to sweep this whole thing. Now, since this line is just on a flat surface, I don't have to worry too much about the reference points, because it's gonna keep it like all set and nicely. So we have something like this. Now, if you see this line, the annoying thing over here is you get like thicker and smaller lines. Now, especially if you want to create, like, let's say, architectural walls, it could be useful to have like thickness being the same at all times. So right over here in sweep, one of the first things that you can solve over here is the angle fix, and this is going to make sure that these in between segments are going to be stretched in such a way that the thickness is always going to remain a size of 1. So no matter how you adjust this is going to make sure it fixes it at all times. So let me just snap to the grid, and as you can see, this can be very useful when creating, for example, the walls of a building. So something like this. Another thing, what you can do with the sweep is fixed flipping. Fixed flipping is used to make sure that it's not going to change or roll over certain things. You have also aim at reference points. This is better if I show this later on. And you have also using vertex. Using vertex is right now, if you look at this shape is being used where it is in the middle. So this, the center point of the shape, is going to be used to sweep along. As you can see, you see the backbone like going directly through the middle. So if you use, for example, the vertex, then it uses vertex 1 of the line to sweep along, or whatever number you use. So in the case when using a circle, and I'm going to make it not a primitive but a polygon circle and connect it over here, then you can see then with using the vertex you can choose whatever point you want to have to sweep along, or it's going to go right through the center. Okay, so this is the first part about the sweep. Perhaps one other thing, it has to do with the skinning. You have skin with auto closure and skin with preserve shape and auto closure. Now there's no difference between each one of them when you're working with polygons, but it's going to be a difference the moment you start changing this into a NURB shape. Let me set the number of points properly. So here we see the NURBs. And if you can see how it's going through this whole shape, you see exactly the result over here. So let me remove over here the grid, it makes it easier to see. So if we're showing the points, you see that the points of the NURBs are exactly placed on that spot. And that's correct. But the interpolation of the NURBs makes sure that you get, like said over here, this interpolated shape. So what you can do as well is you can skin with preserve the shape. And so what it's going to do then is it's going to try to make sure that all these in-between segments are going to be placed exactly on those corners. So it's going to adjust that a little bit. And so then we get a curve such as this. So this is with shape preservation. Now this is important because it also has some other implications as well that we're going to see later. Okay, so let's go back over here to this first sweep. But as you can see over here, we have like these long segments, and we have like segments which have like more curliness to them. And in fact, our geometry over here is not that optimal. Now, to make this more optimal, one could look at how to remove, for example, the points over here on the curve, which are not varying that much. So to do that, we can use a facet node, or we can use a refine node. These are two nodes you can use for exactly the same thing. The facet node is a little bit easier to use, but it's a little bit on a strange place. Now you know, facet is to be used to create all kinds of normal attributes. Now there's something you can do as well, is you can remove inline points. And removing inline points are points which are not having like this big angle. It's to clean up the geometry. So once you do that, remove inline points, you see that we're going to have like less points on straight parts. So if you're going to increase this value, you see it's going to create like this optimized version of that shape. And so if we connect both of them over here, you can see how we create like this sweep with fewer details and less polygonal geometry. So this is really going to help for reducing complexity. Now we can do exactly the same over here, but the difference is with this node you can also set a range. So you see over here the first hue, the second hue, this is actually setting the range what you're going to work with. So let's say if we do it just between this range over here, then we can unrefine this whole thing and make sure that we make those adjustments just locally. So usually you do something like this with the refine node and then you have the same result. So two methods that you can use to give exactly the same end result. Okay. Alright, so once we have this road, the next thing that we want to do is we want to make sure that we have from the grid a projection onto this road. We want to make sure to do the following. We want to have over here on this mountain landscape a set of points which are going to be deformed so that they match up with the road that we have over here. So how can we do this? Well, first of all, we need to make sure that we have the same vertices, or the same points, let's say, the same points from the grid being moved to this road over here. So let's start doing this. We have over here this grid, and we're going to use a grid, and we're going to array that grid towards our road that we have created. So that's what we're seeing right now. So exactly the same thing than what you had to do before with the curve over here. Let's see, you have over here this transform to make sure that this curve is going to float always above so that you can always project it down. So what you can try and do is to make sure that the landscape is going to be placed in such a way that it's always going to be projected onto this road. So try to solve that right now. If you don't succeed in it, I'm going to continue and I will show you what you need to do. So, a few things the same as before. We're going to create like a transform node to make sure that we can move our grid. So the lower we bring it, the better result we're gonna get. And we want to do it in such a way that it goes all automatically. So we can refer directly to the sweep, or even better is we can create again a null node and refer to that null node. So I'm going to be lazy. I'm just going to copy over here what I have. I'm going to put it down here, and instead of null 1 I'm going to use null 2, and instead of dy max I'm going to use dy minus, and I'm going to subtract 1 from it. So in this case our array is doing perfectly its job. Now this is a very small road. Now the thing what we're gonna do later on is we're gonna make using an attribute on this road, you're gonna make sure that we can choose on choosing between the points we've generated over here or between the points that we've generated over here. So it's a little bit like an image blend. So that's the first thing that we're gonna do. Now in order to make sure that it's going to work properly, what we're going to change is over here the distance. We're going to make this much wider so that we have the luxury, or that we can choose on how wide we're going to make this road. So this is an important first part. Okay, so now that we have both of these shapes, let's bring our mountain down here as well using a null. And let me rename this to rough mountain. And bringing this down in the graph will make it easier later on for us to use it again. So now we have the rough mountain, and we have the ray of our landscape. Good. So the thing we're going to do right now is to create a selection. I'm gonna make a selection over here on this landscape, and the selection is gonna make sure that we're going to have all the points necessary to create this mask, and this mask is something we're going to create in an attribute. So how can we select these points? The thing that you need to do is, of course, we have to use a group. Let's start with that. Group geometry. But the thing that we want to do is we want to have like not this white line, but let's say we want to have this curve over here. We want to have this curve in order to select at least a range over here. So that's what we're going to be focusing on right now. So with the grouping, first of all, we're going to select points, because the type we want to have, the attribute, we're going to create it on the points. But that will be clear when I continue. So first, points. Let's hit over here to points. Now, as you can see, everything gets selected. We're going to change that. We're not going to use anything from the number tab, so you can disable this. What we're going to be doing is we're going to use the bounding tab to select something. So if you enable this, you see you have like this bounding box. And this bounding box can be used to select anything. So if we increase the size a little bit, so we have something like this, and you take this bounding box, then you can start moving it around, and as you can see, it selects anything that it touches. You have like multiple things over here. You have also a bounding sphere, in which you can select something, or you can have like a bounding object, so an external object that allows you to select points only. Now this is the one that we're going to use, so switch it on over here and you're going to see the node is going to make a fuzz. So over here it's still demanding to have like a second source, not enough sources specified. So what do? We need to create a volume. So we have our curve, we have what we have over here, this line. Now there are a few things that we can do, but let's say we're gonna start with one method. So first of all, I'm going to create a grid again, and the grid is the shape that we're going to sweep along this curve. So what I can do is I can just copy these, copy, paste, or I don't even have to use that one. I can just directly connect it over here. So now we have like an exact copy of this sweep, but instead of using this line, we're going to replace it by this grid. Now make sure the grid that I'm using over here, and so now make sure the grid that I'm using over here is a grid which has a size of 1 and 2 rows. I'm going to remove the expression over here so I have separate control over the height. So what do we see? We see our grid is being used right over here, but not exactly in the way that I want it to be. So I'm going to change one thing. I'm going to change the orientation, so it's in the XY plane. And so once we see that in the XY plane, we see our shape nicely being drawn over this whole thing. Now the thing what we can do as well is we can start altering the shape, because depending on how high all the mountains are, we need to be able to change this size. But as you can see over here, when I do this, we're gonna have like a lot of self-intersections, and this is something I don't want to have either. So how can we change this? Is by doing the following. In the sweep node, I was saying that there was something that we're going to look at later, and that's over here, the aim at the reference points. So once you do that, it's going to take the reference points as its primary source to look at, and it's going to use the curve itself as some kind of an effector. So you can see this as being the aim constraint in Maya. So right now we have like this reference curve, this curve that you see over here, as an aiming, and this one as an up. If we switch this off, then we have the curve as the aim direction and the second line as an up vector. So this allows you to switch those around. So why am I actually creating these shapes that high? Now I'll show you immediately. So let's start first of all with what we have created over here. Remember that we want to make like a group selection from the rough mountain, and we created this group. And so let's start and reconnect what we have over here. So as you can see, we now have like a selection right over here. So why is it important to have first of all these very elongated shapes? That is, if suppose I would have like these very small shapes and we were going to have, let's say, mountains that are going to be like extremely high, let's say a value of 20, something like this, then you're gonna see it's going to miss several of these things. So that's why when we make this higher, let me just show it over here. I'm going to the grid. I'm going to lock my parameters over here so I can make sure that you can see what's going on. So if we make that higher, you're gonna see it's selecting more and more points. So you need to be able to guarantee that selection. So I'm setting this now by default on a value of 8. But again, you can do this all automatically. Again, you can, for example, connect it with an expression over here with the mountain height. Now let's do that immediately. So what we're going to do over here is we're going to take over here channel, and we're going to take that from the mountain, the first one, and we have over here the mountain height that we're going to use. So this is a value. This makes it like extremely large. That's not necessary. We can multiply it by half to have like half of the height. And so like that we are guaranteed at all times, no matter how high that mountain will be, that we're gonna have like a proper selection. So if we reduce the mountain size, then you can see over here also how these values are going to change. So now it's all adaptable. Okay, so that's one method. Something else what you could do is perhaps the following. That's another valid method. So we swept now just this shape. You could also sweep, for example, again a line. And I'm going to use excenter, and I'm going to use again the curve as a backbone, and again this one as reference points, and I'm going to create again this shape. Now what you can use is also a poly extrude, and in this poly extrude you have like several ways how to extrude. You can extrude like, let's say, over here, or what you can do is you can also make like a global extrusion in which you're going to scale over here. Now global is in world space, so you need to use this. So this is also a possibility. The nice thing about this is that you automatically have immediately closed ends. So the thing you could do over here is, let's say we have this parameter that we used for the grid, making sure the size is automatically added, so we can place that over here as well. And we're gonna make sure as well that in the options that we're closing everything, so also the backside underneath over here. Now only connecting this is not enough, because as you can see, this is just generating the geometry above, and because of the extrusion. Now we need to make sure that the shape is going to be centered. So what can you do? You can just use a transform node, and we're going to transform the node downward downward half of what we have over here. So in this case, channel the poly extrude, and then we have over here the local transitions, and we have the global transitions, global transition TY. And of course it needs to go the opposite direction, and again we multiply this by a half. So exactly the same thing as what we did when we were creating like this function of the line. So it's virtually the same thing. So if you're gonna see it now, you see it's also set exactly on the right spot. So you can choose either one of them. I'll go for the latter right now. I'm going to remove this one. So this is going to be our selection system. So now we have our selection. What we're going to do now is the following. We're going to use this point selection as a selection to create two different kinds of colors. The reason why I'm going to create like two different kinds of colors is that I want to have like a color attribute, makes it easy, makes it visible. A color attribute which is going to determine whether we're going to use these vertices or that we're going to use these vertices. So let's go over here and create that attribute. Now, creating an attribute is just simply by having an attribute create, and you know what you need for color. It's capital letter C, small letter t. So now we have a color. It's already generating the color attribute, but it is complaining. It's saying, okay, it expects at least 3 values, but since it's recognizing this, and it's starting to create already something there. So going to make sure that we're gonna have like 3 values. So as you see, the warning has been removed and we have like 3 colors. Let's set the value to 0. So now everything is black by default. And what we're gonna do is we're gonna make this group as a selection. So with over here group 1, we will see it over here group 1, and if we add the value right now, color of 1, then this is only going to be applied to the selection of points. So the default value is going to be 0 at all channels, and the value that we added is going to be 1. So you can change this as well. And that's the default value. This is the value that we're applying it to. Alright, so this is the first thing that we gonna do. So right now we're gonna use this attribute in order to select either one of those. So this is something you will do with a point swap. And in the point swap you can combine both of these. So what I want you to do is the following. I want you to make sure that using the red color, you're going to make a choice either of these points or from these points. So everything which is black should become like the mountain, everything which is red should become like these points. And that's something you will have to solve over here. So you can pause the video now. If you don't find the solution, I'll explain to you now. So let's see, we have like all this blackness over here. So that's the first input. So this is TY. If we use TY2, we have the second input, which is this result, the one we see over here. Okay, so first TY. TY multiplied with the color is going to give us only at that part the mountain. Now it's exactly the opposite that we want to have. So how can we solve this? Well, in fact we need to make sure that we invert the color. So everything which is black should become red, and everything which is red should become black. So as you can see, we have over here this color. It's a value from 0 to 1, and we're multiplying it, so it's logical that we see the results as we see them over here. So how can you do that? You can do that using a complement. If you do, the formula is 1 minus the color, then you will negate that color. Let me show you this over here using the color as well. So if you add color, if we're going to have like 1 minus the color, you see you get the opposite. It's a very simple formula. It's called a complement. What it does, it reverses the values which are between 1 and 0, or between 0 and 1. So how does it work? Well, if you have a value which is 0, and so this would be, let's say, a variable. If the value over here in this variable would be 0, then 0 minus 1 becomes 1. Now if this variable value would be 1, 1 minus 1 becomes 0. And so therefore you can have always a nice switch. Even also if you have, let's say, a value of a half minus 1 becomes a half, so that remains just in the middle. But if you have like 0.75, and 1 minus 0.75 becomes 0.25. So it's ideal to make an inverse. It's also exactly the same operation that's being used with images. So when they inverse an image, they do exactly the same thing. It is called complement. Okay, so I'm going to remove this back, $CR, back to the original, and I'm going to just keep the color as it is. So now we see this. I can also remove the color, by the way, so we can see the result immediately over here. So now indeed we have on the right spot the landscape. So now I'm going to add something. Now I want to add the position of the road where we have it over here. So in this case I'm going to add $ty from the second input. Now if you do that, we see everything we had over here is being added to the y value. So we don't need everything. We need it to be masked out. So we're going to multiply that thing with the red color, which is correct in this case. And so everything which was red has to be this thing. And so the moment on you do this, you see over here our road appearing. And so now you can just play around a little bit with these values. You could make, let's say, this road a little bit wider. And we have over here the road going over the landscape. So you can just start changing, going back completely to the top. And you can start changing, for example, the location of some of these curves. And you'll see while you're adjusting these curves, the whole road is getting adjusted as well. So that's one thing, and the other advantage is you can now smooth this color attribute so that you have like a softer slope, because right now we have like this really harsh slope. You can make this slope softer. So by adding a smooth function, a smooth not on the geometry but a smooth on the color. And so you see over here we have like a smoothed version. So let's smooth this again, set this to 3. Now this is going to smooth too much. But as you can see, you can really adjust the result, and now you have like a nice mountain road that you can control. Now of course we're nothing with a mountain road without having UVs that we can use on this shape. So this is also something we're going to alter. But for this I'm going to do that in a second part of video lecture.